Good afternoon. So in last class we seen about the DC 3-point starter. So what is the main drawback of 3-point starter? Speed control. You can explain clearly. What is the main drawback in the 3-point starter? What's the main drawback? The current is not sufficient. Yeah, good. So what is the main drawback in the 3-point starter? If you are trying to increase the speed, definitely you have to reduce the field current. So with the help of reducing the field current, you can be able to increase the speed. But beyond certain time, if you are trying to increase the speed by reducing the field current which is given to the no-volt release coil. So the no-volt release coil does not capable to generate the sufficient amount of magnetic power. So it does not, it won't be able to hold the handle. So definitely not. So with the help of spring, the handle is again compared to its original position. So unable to hold the handle because it does not produce the sufficient amount of magnetic power because the field current is very low. So that is the main drawback in the 3-point starter. So the drawback can be eliminated or overcome by using the 4-point starter. So this 4-point starter also can be used for DC circuit motor as well as compound motor. Okay. So why it is named as 4-point starter? Because it has 4 terminals. It has 4 terminals. These are L, F, A and L. Okay. L means line. This terminal is connected with line. And F means field. This terminal is connected with field winding. And this is called A, armature. This is connected with armature. And this is nothing but GAN. It indicates neutral for the protective purpose. Okay. So here, initially, this is a coil. In this 4-point starter, we are using 2 protective coils. One is called overload release coil. This coil is called overload release coil. And another coil is called no-volt release coil. No-volt release coil. So these are the 2 protective devices which are used in the 3-point, 4-point and as well as 2-point starter. Okay. So here it has 6 number of studs. 1, 2, 3, 4, 5 and 6. This is one is called run position and this is called starting position. Okay. So here in between the 2 studs they are connecting the starting resistance. So this is the first resistance R1, second one is R2, third resistance, 4th and 5th resistance. Okay. So here at the last step, from the last step, there is run position. From this run position, the is wire and it will be armature. This run is armature. And this is called a crosser. This where we use the 4-point cutter alone and the 3-point cutter. Okay, so this is called a crosser. This is an connectivity. So in this crosser, we are connected the 2 wires. One is for field. Yeah, the other one is connected with no-volt release coil. The other one is connected with no-volt release coil. From this no-volt release coil, it is connected protective resistance. It's a connected protective resistance. So according to the construction, okay, when the current is given, current to the line, which is entering into the overload release coil. From this overload release coil to handle, again it is flowing to the starting resistance. From the starting resistance, again it is supplied to the armature. So the overload release coil, starting resistance and the armature are connected in series connection or connected in series connection. And what about the field? In 3-point starter, the no-volt release coil and field winding are connected in series. But here, the field winding is here and the no-volt release coil is here. Both are connected in parallel. So in 3-point starter is series, but here it is connected in parallel connection. No is wire and the field is connected parallel. Okay. So why these two are connected in parallel? Because here the current which is supplied into the lower voltage coil. The current which is supplied into the lower voltage coil is always constant throughout the entire operation. Throughout the entire operation, the current which is supplied into the lower voltage coil is always constant. So it always producing the sufficient amount of magnetic power. Okay, but if you go for 3-point starter, okay, so the field current is getting changed. When the field current is getting very low, it does not produce sufficient amount of magnetic power. But here the current is constant, so that it definitely produces sufficient amount of magnetic power. It all the hand. And next, the current through field is also constant. The current through field is also constant, so that we are unable to change the speed. But if we want to make the speed as variable, we have to insert one variable rheostat in series with field control. So by adjusting this rheostat, we can be able to control the flux winding, so that the speed also takes variable. Okay, so initially when the leakage is closed, the line current which is entering in the overload is coil, from this overload is coil, which is entering the handle, from this handle, again now it goes into the off position, the motor is still off position. When the handle is moved from off position to first position, the current which is entering into the armature, which is entering into the all the 5 resistance. The resistance is 5. Or large amount of resistance, so the armature current is very low. Now again it is moved into the shunt 2, resistance will be cut off, so it will be 4. Again it is moved into shunt 3, another resistance will be cut off. If you go for all the resistance will be cut off, the current which is entering into the angle, the current directly just goes into the armature. So initially the current which is going to armature is low. By cut off the resistance, the armature current is gradually increasing, so that we can be able to limit the starting current. We can be able to limit the starting current. Here, current is always there. If you want to make what is variable one, if you want to control the speed, you have to adjust this variable rheostat. If suddenly, if any power failure, if any interruption in the power failure, immediately the current which is entering into the lower coil is getting cut off. So the coil is getting demagnetizing, so it is unable to produce magnetic power, so that it is unable to hold the angle, the angle is released, so that it will be come back to its original position in the help of spring balance. Okay, so that's what is called low volt release coil. That is low volt, the angle will be released. Okay, and the next product device is overload release coil. Suppose the maximum current rate is 20 amps. Okay, maximum rate is 20 amps. The current is exceed beyond 20 amps. This coil is getting energized. It acts as an electromagnet. This electromagnet attracts the iron mixer. This is nothing but a triangular prism. So the triangular prism gets attracted. These two contacts get short-circuited. Where these two contacts connected, it is connected across the lower release coil. So the two telemeter, one is signature, another is outgoing of NBR is gets short circuited. So again, the lower release coil is getting demagnetizing. So we are unable to produce the sufficient amount of magnetic power. So as the angle is again come back to its original position in the top is spring balance. So there are two protective devices we are using. One is low volt release coil, that is low volt. If any power supply, the angle will release it. If the power is overloaded, it can be power supply. So these are the two protective devices which are used in this starter. Okay. So the 3 points, the drawback of 3 points can be eliminated here.